Now let's look at horizontal translations. Oops. Let's go back one page. There we go. All right, so this is in your notes. Let f be a function and c be a positive real number. The graph of y equals f of x plus c is the graph of y equals f of x shifted to the left c units. The graph of y equals f of x minus c is the graph of y equals f of x shifted to the right c units. So notice that the plus is to the left, right, and the minus is to the right. So the plus is technically minus a negative because there already is a negative in the equation. So you can see on the left or the right there, the graph shifted to the, oh actually this is backwards. I don't think this is written in your notes anyway. You could add that, but actually it's in there, but it's written right next to the two blue graphs, and that should go that way. So we have y equals f of x minus a negative c. All right, that would simplify to y equals f of x plus c. So if we see x plus c, that's c units to the left. So notice that the black graph is the parent graph. It moves c units to the left. And if we see y equals f of x minus c, that would be c units to the right. So when a number is added to x, and you can fill this part in your notes, when a number is added to x, it will shift horizontally. If it's added to x, it will be contained in grouping symbols. Parentheses, absolute value bars, in an exponent, under a radical. So add this part to your notes. Under a radical. That says under a radical. Let's fix that R. I don't know if I fixed it, but that's radical, R-A-D-I-C-A-L. There's already a negative in the equation, so negative c becomes x minus a negative c, becomes x plus c. X plus c shifts the function c units left. Plus c becomes x minus c, right, becomes x minus c. So x minus c shifts the function c units right. I think in your notes I accidentally typed plus a negative. It's technically the same thing, but I meant to just put x minus c. So x plus is to the left, c units to the left, x minus is c units to the right. So the blue graph here is y equals x squared. And the red graph is f of x plus 2, or x plus 2 squared. All right, so x plus 2 is the same as x minus a negative 2. This is going to shift the graph 2 units to the left. All right, another way you could think of it, if you have a plus 2 there, it's going to take a number that's 2 smaller just to get to 0, right? Because negative 2 plus 2 would be 0. The parent graph had the point 0, 0. The graph of y equals x plus 2 squared has the point negative 2, 0. So notice it's just shifted horizontally, not vertically at all. And the graph of f of x minus 1, which is x minus 1 squared, is the parent function shifted 1 to the right. We would have to add 1, right, just to get to 0, because 1 minus 1 would be 0, and 0 squared is 0. So the minus 1 in the parentheses shifts the graph 1 unit to the right. So as you can see, a number added or subtracted from the x will cause a horizontal shift or translation, but in the opposite way of the sign of the number. So plus is to the left, minus is to the right. All right, we're going to go ahead and do these two graphs. Use the graph of f of x equals x squared to sketch the graph of each function. And you probably, oh no, you don't have the So you're going to have to do the table with me. You have the parent graph, but not the table. So x, this time we're going to leave a space next to the x because it's the x that's being transformed, not the y. So I can make that neater. Good enough, I guess. All right, so the parent graph is y equals x squared. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Let's see if I can extend these lines because I didn't make it big enough. All right. Let's see if I can cram in the middle column there. So this graph, our horizontal shift is 4 to the left. Right, 4 units left. So for moving left, we're not going to add 4. Otherwise, your graph will go the wrong direction. We're going to subtract 4. That's a minus 4. So negative 3 minus 4 is a negative 7. Negative 2 minus 4 is a negative 6. Negative 1 minus 4 is a negative 5. 0 minus 4 is negative 4. 1 minus 4 is negative 3. Notice they're just going up by 1 because the x column went up by 1. 2 minus 4 is negative 2, and 3 minus 4 is negative 1. So now we have a new x, but we're going to graph the same y values because our graph is just shifting horizontally. All right, so I'm going to graph the points negative 7, 9. So 1, 2, 3, 4, 5, 6, 7. So there's negative 7, 9. And negative 6, 4. And negative 5, 1. Negative 4, 0. Negative 3, 1. Negative 2, 4. And negative 1, 9. So notice the graph just shifted 4 units to the left. The domain is still going to be negative infinity to infinity. It'll be through all the parabolas. And now the range is exactly what it was, right? It's still 0 to infinity, right? We didn't shift it up or down, so it didn't change the range. So the parent function and the transform function have the exact same domain and range. All right, now let's graph the next one. The parent function's there, but we could use the table. So we have x, and so negative 3, negative 2, negative 1, 0, 1, 2, 3. And we're going to leave a space, though we're going to square, as our parent function is y equals x squared. So we'll go ahead and square those values. So negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and then 4 and 9. All right, this graph, we have h of x equals x minus 2 in parentheses squared. This graph is shifted horizontally. This time it is 2 to the right. Right? That minus 2 makes it to the right. It's going to take a value 2 more to get to the same y value. So now we are going to not subtract 2, not if we want it to move right. We're going to add 2. So negative 3 plus 2 is negative 1. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. Of course, these are going to keep going up by 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. And then 5. So this is the new x. Right? If we want to graph the transform function, we have to use the new x and same y. So we have the points negative 1, 9. And 0, 4, and 1, 1, and 2, 0, and 3, 1, and 4, 4, and 5, 9. So here is the graph. Everything has been shifted 2 units to the right. No change, of course, in the domain, negative infinity to infinity. And the range is still going to be 0 to infinity because we only moved it to the right. We didn't move it up and down. So we can just take a parent function and transform our values. And a lot of times that will make it easier to graph. We don't have to find every little point. And the parent function's the same all the time. Use the graph of y equals the square root of x to graph g of x equals the square root of x plus 5. All right, so a parent function for this one, come on, is y equals the square root of x. And every point is not a great point for the square root function. Unless you are really looking to graph, oh man, let's put that someplace else. To graph a lot of decimals, it behooves you to choose values, let's move this over, I can write better to the left, that are perfect squares, right, that are easy to take the square root of. So first of all, there are no negative numbers, right, because as you'll find out in this course, the square root of a negative number is not a real number, it's a complex number. So we do not graph complex numbers. That's a whole different plane. So we can't use anything smaller than 0. And 0, oops, I forgot to leave a space, I'm sorry. So I'm sorry if you copied that. We have a horizontal translation. We have to leave a space for it. So we can use 0, and the square root of 0 is, of course, 0. We can use 1. Square root of 1 is 1. I don't want to use 2, and I don't want to use 3, because they're not perfect squares. But 4 is a perfect square, so let's just skip to that one. The square root of 4 is 2. We don't have to have every little point, right? A few points is enough to graph. And I'm going to do one more because anything else larger than this is not going to fit on the graph. So notice I skipped all the way to 9 because 5, 6, 7, and 8 are not perfect squares. But 9 is a perfect square. The square root of 9 is 3. So 4 points is enough because the next perfect square is 16. It won't fit on the graph, and I don't want a bunch of decimals. All right, so we have x plus 5. Got an extra L in there. The horizontal shift, I wonder if it was in the other graph too. The horizontal shift is 5 left, right? Because plus is really minus and negative. It's going to move in the left direction. So we're not going to add 5 because otherwise our graph would move in the right. We're going to subtract 5. So 0 minus 5 is negative 5. 1 minus 5 is negative 4. 4 minus 5 is negative 1. And 9 minus 5 is 4. And I forgot to graph the parent function. Let's graph the parent function first so we can see our transformation. So the parent graph are the blue points. 0, 0, because the square root of 0 is 0. And that really didn't go in the right spot. Oops. All right, we'll move the graph to it. 1, 1. 4, 2, and 5, 6, 7, 8, 9, 3. So notice the x's are growing a lot faster than the y's. Oh. It's supposed to be a nice curve, not with a weird little glitchy thing in the middle. Nice, smooth curve. I'll do my best, but I make no promises. Yeah, it's not going to. It's not supposed to have a glitchy thing. It's supposed to be a nice curve. And this is not even in the right spot. Let's try it one more time. I'm not even connecting my points here. So I got to find where I can actually write on these. All right, come on, come on, come on, come All right, well, that's as good as it's going to get. But let's see if I do that. Maybe I can connect to these points here. All right, that looks better. All right, so now I'll just erase this. Whoops. And erase that. And we lost a little piece. Ah, no. Come on. I can't reach it. I mean, I can reach it, but I can't. It's not in the right spot, so when I go to move it, it doesn't move. And that's close enough. All right, you got the idea? All right, let's hope for the parent graph is better. All right, 5. So now we're going to graph, the transform graph is better. That's the parent graph. So the blue graph there is y equals the square root of x. Right. The red graph is going to be y equals, or g of x equals the square root of x plus 5. All right, so now the graph is shifting 5 to the right. So now, and this is going to be our new x, and this is our y. So we have negative 5, 0. We have negative 4, 1. Negative 1, 2. So notice no negatives, right, on the y's. That's because you take a square root, you get a positive number. And 4, 3. And let's see how this graph looks. Better. Okay, better. All right, so they're supposed to be the exact same size and shape, just shifted to the right. Now, the domain of this graph is not all real numbers. Right? Notice there is nothing beyond that point there. The domain for the, actually I'll write the domain for the parent function. The domain for the parent function was bracket, that's a D. This whole middle part, I don't know how to just write on the edges. The domain is, with brackets, 0 to infinity. The domain for the transformed graph, g of x equals the square root of x plus 5, is now going to be negative 5, 0, or negative 5 infinity, excuse me, because it's been shifted 5 to the left. And notice no negative numbers, so the range for both the parent graph and the transformed graph is 0 to infinity. All the y values are at or above the x-axis. Right? Because when you take square roots, you don't get negative numbers. Right, there we go. So these are just a summary of our translations. Actually, I think I'm going to stop this video and I'll do the last 4 slides on the next video. So thanks for watching and bye for now.